Good morning. Today we are going to be starting lesson 2.5. In 2.5, it's really all about what is a proof. So that's kind of really what we're looking at here. Now, in 2.4, we did what we call algebraic proofs. So you do like a statement, so you write down your steps, and then you have to give your justifications or your reasons. So this is very similar to what we did in lesson 2.4, only now you're using geometric diagrams, angles, segments, things like that. So just a couple quick vocabulary words. A theorem. A theorem is very similar to a postulate. A postulate is something we assume true. It's kind of like, oh yeah, that makes sense. Like, how would you prove it? You just kind of know it. A theorem is something that we can prove. So let's say a statement that can be proven. Now, we've got lots of different theorems, but this theorem is very similar to the postulate in a way that we did in the last lesson. So remember, we had linear pair postulate. So linear pair basically said if they fall on a straight line like this, then they would add up to 180. So this, again, some of this just goes back to Euclid and what Euclid named it. So Euclid named linear pair as a postulate, and he named vertical angles as a theorem. Because if you kind of take a look at this, let's say 1 and 3, notice they're vertical angles, and if you were to fold these over, so if you were to take your paper and fold it right on the vertex there, these two angles would completely match up. Or we can also do it as like linear pair and then linear pair, and then we subtract this. So there's multiple ways to prove that this is true. So because you can prove it, Euclid called it a theorem. So you're going to see me abbreviate this as VAT. Now, if you were to mess up the last part of this, let's say you were to accidentally put postulate instead of theorem, that's not that big of a deal, and I would not mark you down for it. But just try to get in the habit, and I'm just trying to explain what the difference is, okay? So now it's really on to proof. So I guess kind of the question sometimes is like, what is a proof? So a proof is just, it's almost, think of it like a manual, like when you buy something and it comes with the set of instructions. So let's say, well, the definition, let's say it's like a logical argument using deductive reasoning. But I think of this as like a list of steps to show it's true. I'm trying to think of the right words to use here. So you basically, when somebody tells you to prove something or use a proof to do that, they want you to say like step 1, this is why, step 2, this is why. So you have to lay it out very organized in a list of steps. Now, there's 3 styles of proof, okay? 2-column, which is what I did yesterday with the algebraic proofs and is what you see down below here. So obviously I had to pre-type these notes up in advance, and so I picked a style, and so I picked 2 columns. So I hope you're okay with that. Another one is called a flow chart, which in lesson 2.6, they kind of want you to practice the flow chart a little bit more, so we'll talk about that. And then the third one is called paragraph. Now, I normally like to show you kind of a picture of all 3 of them side by side, but with me being at home right now, I don't have access to a printer, so I can just kind of show you my book. So if you look at this, you have a proof, so you have a given and you have a proof statement, and then this is called a paragraph. So you literally write a paragraph in sentences, kind of almost like step 1, step 2, almost like every sentence is a new step. This is the 2-column. So these 2 pieces are exactly the same. It just kind of depends on the style or the layout. I preferably like 2-column just because I don't like writing sentences. English was never my best subject, so I really prefer the 2-column. I can tell you that if you were to take math, or you were to take math when you get older, nobody really cares what format you use, so it's kind of up to you. You can pick. Let me see if I can quick show you. This would be a style. Oh, here's a good one. I didn't even notice them. This is a comparison of all three. So you see, here's the 2-column. Here's the flow chart. Now this flow chart doesn't look too bad because you see how it just kind of goes straight across, and then the justifications or the reasons are on the bottom. So this one's not too complicated. And then you can see the paragraph right there. So that's kind of a comparison of all three. I've seen some flow charts that get a little bit crazy. Here's one that's not too bad, but there are some that get a little bit all over the place. Let me see if I can find another one. Oh, look at this one. This one's kind of crazy. Do you see how you've got like 2 different rows and then they kind of merge together? I think sometimes the hardest part about flowcharts is if this is the style you want to do, you have to create this. Like you have to draw this whole thing out. So preferably, I just don't love it. If you notice the one over here, notice how it goes vertically. So sometimes flowcharts can be confusing for kids at the beginning when you're learning them because there's a few different layouts and styles, and they can both be correct. So let's just stick to 2-column for now because, one, I already typed up your lesson or your notes, and I think it's the easiest one to learn at the beginning. So couple things when you start a proof. So we're going to start with this. So they're telling us that angle 4 is congruent to angle 1. So you want to recopy that. Now you could drop the little m's. That's probably not that important, but you want to keep the rest of it. So you pretty much copy your given word for word and you say given. So those are kind of 2 free points. You should always get those. Every blank spot is worth a point. So in this particular case, it would be worth 5 points because there's 5 blank spots. Now, in this chapter 2, I will always tell you how many steps there are. So you'll kind of know when to stop. As we progress, by the end of this course, you should be able, this should be able to be blank, and you should be able to do it by yourself. Now, the last statement is always the prove statement. So this is going to get copied here, but sometimes I don't like to do that at the beginning because then you might have a tendency to want to use it. So let's hold off on this, but you do not get to write the word prove over here. This you actually are going to have to come up with a justification, okay? So we're going to mark this. We've got angle 4 is congruent to angle 1. Now, we're trying to get to 4 being congruent to 2. That's kind of our goal, okay? And so you kind of want to try to come up with a plan, like how you're going to do that. And what I'm kind of noticing is these 2 are equal. So these 2 are vertical. And notice there's a hint right there. So these are vertical angles. So I'm going to say angle 1 is congruent to angle 2. Now, this side is also vertical. So if you want, I could fill that in right here. Now give me a second before you copy this down. So this would be fine. However, this is not going to help you. So this particular piece right here is not needed. So sometimes you might find that you write something down and then you're like, oh, I don't really need it. That's why I always prefer sometimes to tell you to use a pencil because at least you can erase. If you use a pen, then you have to scribble it out and it just looks messy. So notice, do you see how the 1 is repeating? So basically what you're going to do is you're going to take this out and you're going to replace it with a 4. So this is going to become 4 is congruent to 2. Look up at your prove statement. That's what you wanted. But we're not allowed to put prove here. So we have to say, well, how did we combine the 2 steps? How did we combine these to get to the 3rd step? And I would just say substitution. Now you could use the transitive property here. The transitive property would also work, but personally, I like substitution. And we talked about this in the last lesson. Transitive sometimes does not work, where substitution always work. So substitution is a little bit more of a universal property, but sometimes in multiple choice, you won't see substitution, you'll see transitive. And that just depends on the author of the book, okay? So make sure you can kind of interchange those in your head. Now, when we turn the page here, notice there's 3 more. There's only 3. I wish I could wave a magic wand and tell you, you always do this. The only thing I can tell you that you always do is you always recopy the given and you say given. You know this is going to be the last line, but again, I would hold off on that. But you at least know it. So if this proof, again, is out of 5, if you don't get 3 out of 5, then that is your own fault. There's no reason you couldn't get that many points, okay? Now the rest of it, you do have to do some thinking. So let's mark this. CBD, which is right here, is congruent to angle D. Now the goal is to get ABE, which is right here, congruent to D. Now again, think in your head, what do you know about those angles? Okay, so if we look at the hint, it says ABE is congruent to CBD. Well, what kind of angles are they? So you have to ask yourself, what are these? Are they linear pair? Are they supplementary? What are they? And you should be saying they are vertical. Now, always look inductively, so look for a pattern, at what's repeating. So do you see how this repeats? So basically what I'm going to do is, since these are equal, I'm going to take this out and put the D in its spot. So notice my last line there. ABE is congruent to D, and that's good old substitution. Now, I will tell you the substitution property is one of the most commonly used properties in geometry. So I don't want to tell you to guess it, but typically it is used. Now, some kids will say, is it used every time? Let's say probably over 95%. So majority of the time, yes, it's going to be used. But I'm sure there's a proof that they might throw at you, like, you know, maybe 1 in the whole assignment that won't use substitution. So it is very, very common. Okay, so you notice there's 2 proofs left, and these are both dealing with segments. And so if you want to pause it here and try it on your own, go ahead. Otherwise, again, you have control. You can pause the video at any time and you can try them. Otherwise, I will walk through them. So number 1, once again, is still worth 5 points. If you notice down below, this one is worth 6 because we got a little bit bigger, but that's okay. We have M is the midpoint of AB. Got to kind of write small to squeeze all this in. And AM is congruent to EF. All right, so I'm going to take this piece by piece. It says M is the midpoint of the segment. Well, if M is the midpoint, based on the definition, that means that this side is equal to this side. So I'm going to say the left side is congruent to the right side. And that's definition of midpoint. Now, it also tells me that AM is equal to EF. So I'm going to mark that. Well, notice my tick marks. If these 2 are equal, then all 3 are equal. So once again, kind of look at your piece here. Notice, oh, this says BC. There's not even a BC on here. Sorry, this should be BM. I did not notice that. I apologize. That's BM. There's not even a C in this diagram. I must have just mistyped it. Okay, so notice we have AM repeating, and so we have MB or BM. We can reverse those letters to EF. So basically what I'm doing, again, is like almost like taking this out and like putting this in its place. So I'm going to copy it as BM is equal or congruent to EF. Now, would it really matter if I said MB here? No. That is the reflexive property. Some teachers might want you to do that, might want you to use an additional step, but we're not going to worry about that for right now, okay? So notice we have BM and we had MB. Otherwise, the other thing you could do is you could just go up here and you could just switch this and you could just label this as BM so that it's like in the right order and then you don't have to add an extra step. So again, some of those little details we're not going to be overly concerned about right now. Okay, it's just like if you forget the T and you put a P for postulate. Some of those fine little details, I just want you to learn the style and the idea. So we removed this and we put this in its place, so we're dealing with substitution again. And then I'd be done. Again, you're seeing substitution. Okay, again, if you'd like to pause the video, you are welcome to pause it and try number 4 on your own. You have control. Okay, given M is the midpoint. So M is the midpoint of this segment. So imagine breaking this a segment like that. So that means that the left side, is equal to the right side. So see how they already gave me that. But I do that because of the word midpoint. So definition of midpoint. When you see a vocabulary word, it's typically going to be definition of that word in one of your lines because that's the only way to be able to use it because you had to know the definition. All right, now this one's a tricky one. Segment addition. We know what this is. Remember, segment addition tells us that you're going to take a little segment plus another segment. So it's going to be something plus something to get a bigger segment. But if you look at this, I mean, I could do the whole segment. I could do like everything. So let's use this kind of as a guide, okay? Let's use this. It says MT. Well, MT is over here, so there's not really much to do. But let's look at this. This says RS and SM. So what if we focus on this side? And what if we use segment addition on this piece? So let's go RS, which is the left, plus SM, which is kind of the right, is equal to the whole thing. Now, sometimes you're going to write something down and you don't even know if it's right, but you're like, what else am I supposed to do? Like, I don't know anything else to do. So you just write it down and you see if it helps you, okay? Now you use your inductive. You know this has to come to the next line because that's the final step. But notice it's the same, but notice this is different. How do they get rid of this and switch it for that? And if you notice right here, do you see how RM is the same thing as MT? So you're going to take this out and you're going to put this in its place. Now, you could either write it like this with the RS and SM on the other side and then just put MT here. These two are the same. Or again, if you wanted to, we could reverse this. We could reverse this statement and we could just put RM on this side and that equals RS plus SM, so that now when we replace this piece with the MT, it's right where we wanted it. So it would be MT is equal to RS plus SM. As long as you have this combination in the line, I'm not overly concerned with is the MT on the left of the equation or the right. You just need the main concept of it, okay? So then this would be substitution again. Now, if we were in class, one common question that I typically get is, does substitution happen at the end of your proof? And I would say typically in a shorter proof. So see how this was only 3 steps and this is only 4 steps? Typically, substitution will come towards the end, but it does not have to be the final. As we get larger and larger proofs, maybe we'll get up to like 6 or 7 steps. You might see substitution used a little bit higher. It's typically never used in line line 2. It might be a line 3, line 4, somewhere in there. Just kind of all depends on how big your proof is, okay? But there is no magic answer for me to say you always do this, you always do that. The only thing I can tell you is you always recopy your given, and then you say given. And then the last line is your prove. You will always get 3 out of how many ever points it's worth, okay? And so again, in this chapter, we will give you the number of steps, and we will typically give you a hint or two, but then the rest you should be able to fill in on your own. Now, also, please know that 2-6 is very similar to 2-5. So in a way, you're almost getting 2 days of proof work. So tomorrow's lesson is not a ton of new information. Well, that concludes 2-5.